Uh, okay, so this is an AND logic gate, and the way that this works is that both of these transistors back here have to be active in order for this LED to work. I unfortunately do not possess a switch, but I just have to connect these cables down here like such, and once I connect this one, the LED is supposed to turn on like that. This one only works like this with this gate right here. Both switches have to be active in order for the LED to turn on. If I remove one switch, be it this one, it turns on, and same thing goes for the other. Okay, same thing goes for the other one. If I connect it back up, it turns on. So that is an AND gate. So right here in Tinkercad, I have an AND gate, and it works essentially the same. The resistor, the transistors, and the LED is off, and it will not turn on unless both switches are on. And this right here is an OR gate. The way that it works is with this logic table right here, in which at least one switch has to be active in order for the result to be active. I'll show that right here. If I connect this one right here, the LED turns on, and so will this other one. It turns on, and it will stay on if both switches are connected. Right here, I have an OR gate, and it's once again is just the same as I just showed, where the LED will not turn on unless at least one of the transistors are active. Here is a NOT gate. The way that it works is like this, where if it receives any sort of input at all, it will turn off. There needs to be no input whatsoever for the LED to turn on. If I remove the switch, the LED will turn on like that. The way that this works is by the charge will always follow the path of least resistance. In this case right here, the path of least resistance goes through the transistor and onto this cable to the negative and to the ground. But if you remove this switch, the charge no longer goes through the transistor. It will now has no choice but to go through the LED, activating it in the process. What I have right here, it's the NOT gate, and once again, as I showed, the LED will turn on as long as the transistor is off. If I turn on the switch, the LED just turns off. This is once again done by giving the charge two paths, and because and because you always go through the path of least resistance. When the transistor is on, this is the path of least resistance. When I turn it off, the LED is the new path of least resistance. And just for fun, here is a NOT OR gate. I know it looks like a mess of wires. But how it works is very similar to the NOT gate. If there's any sort of input on the transistors, the LED will just turn off. Let me demonstrate. You can see it right there. Hold up. Sorry. And then if I also try to input in the other one, it will as well turn off. If there's an input in both, it will stay off. And the way that it works is essentially the same as the NOT gate, for following the path of least resistance. And if there's no path on the transistors, it is forced to go again through the LED, turning it on.